Hello, and thank you for joining us. Our webinar today is Let Robots Do Robot Work, presented by Jacob Harrington, our Technical Product Manager for Teledyne CTEC. We will be taking questions, so please feel free to submit them throughout the presentation, and Jake will address them at the end. This webinar is being recorded and will be available within a few days. Okay, I'm going to go ahead and turn it over to Jake.
All right. Shelley, thank you for that short introduction. And I want to thank everyone who's attending already. It's great to see we've got so many people interested in this new system. So we talk about let robots do robot work. And it's really kind of a trend that we're seeing more and more in the marketplace. We're seeing more need for automation. And it's something we at Teledyne CTEC are trying to embrace kind of across the board in producing not only better sample introduction accessories, but also some better sample preparation options. So what we're talking about today specifically is our new APS-7650G Gravimetric sample prep station, which is designed to automate the ASTM D5185 and D4951 sample preparation requirements. So before I dive into the product, I want to give a little bit of a background on the market, just because I think it's good to kind of touch base for those who may not be intimately familiar. So one thing that I know personally I didn't know even 3 years ago, but that I've grown a lot into is that there's really kind of two halves to the oils analysis marketplace. At Teledyne CTEC, in the past, we've worked a lot with the used oil analysis specifically, where you're talking about in-service wear metals or condition monitoring laboratories. That's for the analysis of lubricants that are currently in use to track wear of engine components and degradation of the oil itself. They tend to be very high sample throughput laboratories because they're doing trend-based analysis where they'll take samples over a certain amount of time and they'll recheck the oil repeatedly to see if levels of any of the elements of interest are going up or potentially going down. It doesn't really have to be truly accurate, but what it has to be is very precise and repeatable because you're looking for a change in that trend. On the other side of the market is the new oils analysis. We're talking about blenders, formulators, refineries, really anyone who's in the production of oils and lubricants. They analyze these newly produced products for QC requirements. So they tend to have low sample throughput, but essentially they're checking the raw materials that come in and the finished products that go out to make sure that they're able to meet their cleanliness requirements, make sure that the additives are at the right levels, make sure they don't have any contaminants from their production processes. It's all done to QC requirements, and it all has to be done as accurately as possible. So accuracy is critical, as is cleanliness. Both of those are really, really high priorities for the work being done. So the testing they're actually doing, I mentioned, is quality control. So for quality control, they're actually very strictly following the ASTM methods, typically, for D5185 or D4951. And those methods require dilution by weight. This is something that many of the labs who say that they follow kind of use them as a guideline. They don't do the dilution by weight simply because it's too time intensive. But for new oils laboratories, they really have to do it by weight. And there's a few reasons for that. Now, first of all, I should say that even though the samples are clean, I mean, these are new, clean oils, the dilution is still required basically to deal with the type of products that we're trying to analyze. So in order for proper aspiration and nebulization to occur, you have to still dilute the product so that it can be nebulized into the ICP. Otherwise, the nature of the viscous oils would simply make it impossible to aspirate and nebulize. Diluting by weight is really critical because it increases the accuracy, which I mentioned is the most important thing. And it's particularly important with these types of samples because of their different densities and viscosities. Even a single production site, they're going to make a suite of different lubrication oils for different applications, potentially different parts of the industry. And they can have very different properties, very different additive mixtures, very different viscosities, and as we learned, even very different colors, right? They're very, very disparate products that all need to be analyzed in a fairly uniform fashion. So dilution helps with that. But also it has to be done by weight because that helps compensate for the changing densities and viscosities, which means you simply can't do that volumetrically and get really accurate results. Also, vortex mixing is recommended in the ASTM method for proper sample homogenization. It's actually recommended that you mix the sample before you aspirate or draw the sample out of its container, and then that you mix again after you've added the diluent to your sample to make sure that it's really well homogenized. The typical dilution is actually pretty similar to the used oil market, where you're usually doing a 1 to 10. Most of the time it's in kerosene or similar solvents, and typically it's going to be spiked with internal standard, and in most cases that's cobalt. The more viscous solutions or samples may require heating or may require additional dilution. Often that's handled as a two-step process. So typically what's done is they'll do an initial dilution that may be a 1 to 100 or 1 to 1000 that may include heating. And then they'll still do the secondary step, that 1 to 10 dilution, because the first dilution they'll do with unspiked solvent, the second dilution they'll do in the spiked kerosene to introduce their internal standard and make sure that that's consistent. And currently, for these labs, it's a manual process. So here's kind of a step-by-step of what that would be for every single sample, okay? So you'd start by prepping your notepad with your sample information, make sure you've got your sample names on there, you've got space for all the weights that you need to record, place an empty tube on the scale, tare it, you weight, then you pipette your raw sample into the tube. And one thing that you have to understand when working with oils and trying to use them with a pipetter is that trying to get them to go into and out of a pipetter means that you have to wait. Like you put pressure on and then you wait for the liquid to slowly move into the pipette tip or the pipetter. And then when you're dispensing it, again, you kind of have to, you squeeze it or you push it out, and then you try again and try again. And sometimes with really thick oil, it takes a long time to just allow that liquid to move because of how viscous it is. So you pipetted that in, you record the weight, then you do your best to carefully add diluent to a 10x volume. We've talked to customers about how accurate this process has to be, and some of them said, well, we really want it to be within 5%. Others said they shoot to be within 20%. So the kind of windows of how acceptable or how close it has to be varies quite a bit, but they do their best to try and be accurate about it. And then you have to record everything, right? You have to write down your sample weight, write down your final weight. You then have to mix the tube on the vortexer for 20 to 30 seconds, possibly more, right? You check and see if it's homogeneous. If it's not, it goes back on the mixer. And then once it's finally well mixed and diluted, then you put it in the tube rack and you repeat, right? And you grab the next sample, you do it again and again and again. Once you've gone through and done all those, then you place that rack on your auto sampler for sample introduction to the ICP and manually type in all your sample names, initial weights, final weights into the ICP software, and possibly uncap your samples. And one thing I want to point out is there are an awful lot of potential opportunities for error in this process. It's so easy to accidentally pipette out of the wrong sample tube, or accidentally write down the wrong number, or accidentally type it into the computer wrong. And there's a lot of manual steps here, and every manual step is an opportunity for error. So the more that we can automate these processes, the more opportunities for error that we can remove. Now, this becomes a major pain point. As I mentioned, it's a manual process, and it's tedious, it's time-consuming, it's error-prone. Normally, it takes about 2 to 5 minutes per sample. One thing that we learned in doing investigation is the customers we talked to, how long does it take you to prepare your samples? A lot of them said, oh, it only takes us 30 seconds to 60 seconds or something like that per sample. But when we asked customers to actually time themselves, there was the perception of how long it takes, which turned out to be very different from the reality of how long it takes. So someone who's experienced, knows the process really well, and kind of gets into their groove, they may be on the low end of about 2 minutes per sample. But we know that a new analyst, someone who's just starting and learning the process, they're going to be up about the 5 minutes per sample. When I went through and did a bunch of this for our marketing department, it took me 3 to 3.5 minutes per sample. And if you average out about 3 minutes a sample, that means you're preparing 20 samples in an hour. So just to prep those 20 samples for analysis, you're standing there for a full hour. moving your arms around and shaking and stirring and pipetting. So it's, like I said, it's a pain point. It's a huge pain point, and there's currently no commercially available automated solutions for sample dilution of oil by weight. The only option available to this point has really been to get something custom designed, and that's usually at very, very high cost. So with that in mind, we're introducing the APS-7650G gravimetric sample prep station. It's the first commercially available automated solution for preparation of oil samples by weight. It's really it's a first of its kind, and it's got a lot of new technologies and features that make it work as accurately and cleanly as it needs to meet the market, to really meet the market needs. So I took you through kind of the manual process. You saw all the steps there. Here's the automated sample process. So you may have an additional pour-off step, depending on if you can dilute directly out of bottles or if you need to transfer your oil into a smaller container. Once you've got your raw samples, you put those into a rack. You put empty tubes for the dilution tubes into a sample rack. You place both those racks on the 7650. Then you can create your sequence. I'll show you how that's done with your sample names, or you can simply import a file with the CSV file. You can, if you have your sample information in a CSV, you can import that into the software, and that takes 2 seconds. And then you start your run. And the great thing is you then get to go do all the other things that you need to do. Once it's, it does the tedious work, right? Acts as the robot and does the repetitive over and over again type of actions. And then once it's done, it will play you a song and say, hallelujah, we're finished. And then you go grab your racks, throw them on the ICP. And one of the other really nice things is when it finishes preparing your samples, it will also export sample data, again, into a CSV or a CIF file, which can then be directly imported by the ICP software. So you don't have to do any of the manual data transfer. All the weights are automatically recorded, exported, and then you just import those into your ICP software and you're ready to run. So we talked a lot about it. I'm going to show you in action. We've got a little video that I want to share here. Make that full screen. So we've got the manual dilution on the left, our automated dilution on the right. And you can see the first thing that we do on the automated dilution is putting empty tubes into the cups, or into the rack, excuse me. Now he's going to start prepping his bottles. The setup here is only for 5 samples. And even with that, the video took a very long time. So our marketing guys at the end of it are saying, okay, yeah, I get why we want to automate this process. Because it really is, it's very, very time intensive. On the left, first thing he had to do was write down the sample information, because he's got to collect all the information on a notepad. And then he'll continue to take notes as he goes through the prep process. Right. Now, the automated system, he shook up his samples, he's got his empty tubes, he's already walking away from the prep area. Those go onto the auto sampler. In this case, we're using the bottles. So if you did want to use sample tubes or sample cups for your raw containers, then you might have a pour off step. And then what I've done there is you just import the data file and the system is running. Okay, so it took a little over a minute to get the samples racked, transfer them over, and start the run. Now, obviously, if you were doing a full rack of 45 samples, it'd take longer to do the prep, but not too much longer. And the great thing is that you get to walk away. So by the time we're about halfway through preparing the first sample manually, all the manual work was already done on the automated system. And that means that the analyst gets to walk away and do other work. Right? There's a lot of tasks that have to be done in the laboratory every single day. You're refilling your rinse solutions, you're doing your sample handling, you're emptying your waste containers. There's phone calls and meetings and emails and QC reports and all these other things that have to be done that take up our time. Not to mention all the other analyses that you have to do. Now, you'll notice we actually sped up both the automated and manual prep videos on the top. That's because we didn't want to take 15 minutes of this presentation just to sit here and watch the systems run. The other thing you'll notice is they're sped up evenly, and really it takes about the same amount of time to do the manual process as it does to do the automated process. So the time is still there. The great thing is that you don't have to be. You can be off handling other duties. So I wanted to mention a couple things on the automated prep. You see it's currently adding the sample. The tip goes and gets dispensed there into a little waste bin, and now the diluent and vortexing occur simultaneously. So we found that doing those together actually gives much better results. The sample, the final weight's gathered, and then it goes on to the next system with a clean pipette tip. And the process continues. So like I said, I mean, the really nice thing is the work still has to happen, but you don't have to do that, right? You can get an automated solution that can handle that sort of tedious labor for you. And what that really introduces, I mean, we showed a bunch of different little clips, but to me, the big question is, what will you do with the time that you save? What would that mean for your laboratory, for your staff, for your team? So now we're going to dive into a product overview. I want to highlight some of just kind of the overall features of the system. And then we'll go into more details a little bit later. So when we were speaking to customers about what this system needed to be to meet the needs of their laboratories, the pinnacle, the most important thing for everyone that we talked to, I think it was very much unanimous, was that it has to be accurate. If it doesn't do the job well, it doesn't help us. You know, it doesn't matter how flashy it is if it can't do the work. So accuracy was first and foremost in our design. And here's a few ways that we approach that. So first, each dilution tube is weighed 3 times on an integrated balance. So that means each tube is weighed individually. It's weighed when it's empty, it's weighed after the sample is added, and it's weighed after the diluent is added and it's vortexed. The scale itself is fully integrated both into the system and into the software, and is accurate to plus or minus 0.1 milligram. The sample is aspirated into a clean pipette tip by a 2.5 mil integrated syringe. So we actually have a syringe that's built onto our Z drive, into the kind of the horizontal drive, or excuse me, the vertical vertical drive that goes up and down. And that syringe controls all of the sample movements. So all the sample movements are handled by a very accurate syringe that actually pulls an air gap prior to aspiration. And then I mentioned before that you kind of have to pause, right? So the system does pause after sample aspiration. It'll go into the tube. The syringe will move, create pressure, and then we actually let it just sit in the oil for a few extra seconds to allow that oil to flow into the pipette tip. Because we found that that's really important, especially for the heavier oils, to give that a little bit of extra transfer time. We have liquid level sensing that's active on every single sample. Doesn't matter what kind of a container you're working with. And what that does is it really ensures that there's minimal oil on the outside of the pipette tip and that the whole system remains really clean. And we have a 2-stage sample dispensing. So it automatically adjusts for lighter or heavier oil as far as how much oil it actually puts into the sample tube. It can dilute anywhere from 10x to 100x, and it can do samples up to a viscosity up to 1,000 centistoke. That's not to say that something above 1,000 centistoke couldn't be run. You know, that it's definitely potentially in the realm of possibility and can work. We've done some testing that has shown that some of the samples up there we can still run on here, but that's kind of the limit of, we are very confident. Below that point, above that point, it may still work, but we're not going to, you know, absolutely guarantee it. So second, it's capable, and this kind of goes hand in hand with being accurate, right? Some of the ways that we have additional capabilities added is the software will automatically adjust the diluent volume to match your sample mass. So that's a really nice thing about having the sample mass actually recorded, is then we can have the software do the math in the background to determine exactly how much diluent should be added. And that really helps to compensate for varying viscosities, because depending on the viscosity of the sample, you'll get more or less actual sample mass into the tube. It also ensures that the desired dilution factor is achieved. And the fact that that dilution factor is is achieved is particularly important if you have your internal standard in your diluent, because that ensures that it's consistent across the board. We have an integrated vortex module, which allows the user to program the mixing time to meet their needs. The default is 20 seconds, but for really difficult or heavy oils, they may require additional mixing time, and that's programmable. So you could set up all your samples to use the additional time, or you could isolate specific samples that you think will need more time and do that on a sample-by-sample basis. The optimized diluent addition protocol ensures that vortex mixing is as effective as possible. We've done a lot of work to try and come up with, we've gone through a lot of iterations of our diluent addition and vortex mixing process. And at this point, we've reached what we believe to be a fairly optimized protocol. And it works really, really, really well. We've been able to get very, very good homogenization out of the process, even with heavy oils kind of on the upper end of our limit. And we also have automated diluent density discovery, which allows users to optimize performance with their diluent. So what I mean by that is the system will actually, you can click a button in the software, follow a couple little instructions, and it will add a known quantity of oil to a sample tube, essentially weigh the tube empty, weigh it with the added oil, and from that determine the density of your specific solvent. You can also, if you know the density, you can type it in manually, but you can also have the system automatically determine that for you, and it works really, really, really well. So we've been really happy with that. It makes it easy to switch between solvents, or if you're concerned about, we made a new batch and I don't know if the density is going to be identical, you can use this to just make sure that everything is exactly what you want. And clean. I mentioned, accuracy and cleanliness are critical. So let's talk about how it's clean. So we make a promise of zero carryover. There is zero sample-to-sample contact, and that's because we use a different pipette tip on every single sample. That integrated pipetter ensures that there's always a clean tip, and it automatically checks for the presence of pipette tips and will recognize if there's not a tip there and respond appropriately. The system uses what we call active drip retention to prevent cross-contamination, which essentially means that after it aspirates the sample into the pipette tip, while it's traveling and waiting for other things to happen, it will continue to aspirate very slowly. So if there's any oil on the outside of the tip that might try to drip off, or if the oil inside the tip for any reason starts to drip out, that will be aspirated up into the pipette tip, so everything's maintained and kept really clean. There is no rinse solvent needed on a sample-to-sample basis. Essentially, all your sample will contact is the pipette tip, and then the sample tube it goes into. So the pipette tip is disposed of, and your sample tube goes into the rack. That means there's not anything that has to be rinsed in between samples. So very, very minimal rinse solvent usage. Essentially, the solvent usage is what's going to be going into your sample tubes as diluent. And then the pipette tip waste bin can easily be removed and cleaned. It's simple to slide off, dump out, wipe out, and put back in place. So, and we talked about accuracy, we talked about cleanliness, and obviously these come first. That was the most important thing. But once our beta users got comfortable with the system, what really impressed them is how much time that they saved. So we had a beta site that reported up to an 85% decrease in the time spent on manual preparation, which is obviously that's an enormous amount of time that can be saved on a daily basis. And they said that it was like having half a head count added to their lab, which, I mean, obviously that's huge, especially right now. I know a lot of labs are struggling to maintain headcount, keep people trained, and this is one less process that you have to have someone do manually. And then the other thing that I always hear whenever I talk to people about a dilution system, they always ask about the software. Okay, that's a huge question, because even if the hardware is great, if the software is terrible, the whole overall system is still kind of janky. So what about our software? We say it's user friendly, and it absolutely is. It's incredibly easy to use. The daily work can be started with about 3 clicks. As I mentioned, it does have import-export functionality so that all your data is maintained. You can import your CSV file that has your sample names, and then your sample names with all the associated weights is exported for import into your ICP software. And the really critical thing is that allows you to never incorrectly key in a weight again, because you don't have to type any of it in. So with that in mind, I do want to do a quick software demo. So I'm going to pull this up. Hopefully this is all showing well. This is the Oily software. And it's honestly, it's pretty straightforward. I'm going to start with the config page and kind of work my way back. So this is the configuration page. There's a few features I want to highlight here. So right in the center, you have your tray layout. So this is how the deck is set up as far as what types of bottles and racks you're going to use. Your sample rack, you can pick from a list of different potential sample racks. And then also, of course, your dilution rack. What am I diluting out of? What am I diluting into? And we do have custom rack options available as well. Your sample probe depth, that's just setting a maximum depth of how far down you allow it to go. And then I mentioned the finding density. So there's a button here, and this one and the gripper height, they're very simple. You click a button, and then it basically will pop up with a little picture and some instructions of, place a tube here, click go, and it takes a minute. And that helps maximize or optimize all of our calculations to match your diluent, and also maximize our efficiency with the gripper. On the left, we have the outro here. So that's any WAV file can be used here. This was a highly customer requested feature that we maintain with new systems, was that they really liked having something that would play a song and notify the lab of, hey, this work is complete. The manual controls page, this is kind of a service page, but allows you to check the vortex mixer, check the balance, do your maintenance on the syringe maintenance that's needed, and move the probe around the deck. Your method page, this is really simple because essentially what it is, you decide your dilution ratio and your vortex time. So the dilution ratio, the way the system's designed to work is you set the dilution ratio, and then from that we try to determine the optimal sample volume to add to the sample tube. So that's based off your dilution ratio, and it'll automatically adjust. And the goal is always to get to somewhere between 8 and 10 mils of final volume. But with the different oils, obviously we're going to get different masses. Some things transfer easily than others into and out of the pipette tip. All that's automatically compensated for in the software, the hardware in the background, so that you don't have to fight with it. But it does mean that really what we're giving you is you get the option to select your dilution ratio, and then we try to provide the optimal result for that dilution rate factor all the way through to the end. And then I mentioned the vortex mixing time. That's programmable to meet the needs of your samples. Your export page, essentially you can select what type of file type you want it to export as and where you want it to export to, and then what parameters you want to have saved in that file. And then that's pretty much it. So this is the main page where you'd spend almost all your time. Most of the rest of that is kind of setup information, and that's the whole software. Like there's not a lot to get lost with here, and not a lot that you can do wrong. The main page, your sequence page, I'm going to show you a couple different ways that you can load this. So first is you can add it manually here. If you wanted to do a batch of 20 samples, you click those 20 samples, and it'll show up over here in the top right what your starting sample tube and ending tubes are. Then you select where you want them to be diluted to, and starting pipette tips. By default, it will start in the first position. As long as the software is kept open, it will remember the last located pipette tip that it used and automatically start with the tip that goes after that. But if the software's been turned off and restarted, then you'll need to tell it actually where to go look. So maybe if you've already done a 1 to 20 previously and those tips are gone, you're going to start with position 21, for example. And then down here, you'll select your sample name and a postfix. So this can be really anything you want as your sample name. I know people log their samples a lot of different ways. And then your index essentially would be where you want it to start counting, whether that's 1, whether it's 162, whether it's 1,380. You type that number in and it will start counting from there. And then you select your method, hit new sample list, and there you go. Your sample list is created. So it's really that simple. It's very, very straightforward. The other alternative to this I'm gonna go ahead and clear this sample list out, is to do an import, which is actually even faster. If you got your CSV file ready, then you just hit import that file and it pulls in all of that. So your sample name information can all be in there in the file. And then basically you have your sample tube, dilution tube, and your method. And the software, of course, comes with an example, which is actually what I just loaded to show you how to build your CSV file, but it's very, very straightforward. And then a couple other things I want to mention. All these buttons are grayed out. That's because I'm not attached to a system right now. Otherwise, obviously the start button would be there. We do have the option, a couple options I want to make mention of. One is the add rush samples. So this essentially would be like if you wanted to re-prep something, or you had something that came off the ICP that you need to run again, or maybe something comes in the door that you need to put to the top of the list, you can hit this add rush sample button. What that'll do is it'll bring up the sequence or the page that we just looked at for you to select where you're diluting out of, where you're diluting into, what you want to call it. And that will actually insert the rush sample will go at the very top of the sequence page, as you see here. It'll be run preferentially, and then it will give you, and actually the software will pause after it finishes the rush prep to allow you to take that sample tube with you. So you click, okay, I've got it, go, and it will go and finish. The other thing I want to mention is the schedule start button over here. I know it's a little hard to see, but essentially the software will allow you to schedule it for when you want it to run, which can be really nice. If, for example, you were going to run overnight or early the next morning, you can load up the sample deck with 20 or 45 or however many samples, load your batch on there, and then say, all right, I want you to start running at 5 a.m. tomorrow morning, so that when I get in, everything will be freshly prepped. I can grab my samples, that'll all be diluted, throw them on the ICP and start my day. And the great thing is that you can start your day with samples that are ready to analyze instead of starting your day with several hours of tedious sample preparation. And then the last thing I want to mention is right at the top, there's a progress bar. So it'll show you, how many samples it's prepped out of total, your estimated time. The estimated time is kind of based on a generic dilution. What it actually will do is it'll kind of check on itself. So it'll run a sample, and then based on how long the sample takes to prepare, it will adjust the remaining time that it thinks it'll take. And then the bar right underneath that, that's all gray right now, that will turn blue so that you can glance at the software across the room and get a sense of how close to complete everything is. So that's the software. Like I said, it's very user-friendly. We tried to make it very accessible, and we've gotten really, really good feedback on it from our users, beta sites so far. So that's been great. Now I'm going to dive into some product details. We have a lot of features on this system, including the pipette tips with their custom rack and stripper, the integrated balance with cover, the integrated syringes on the Z drive. There's also the Cavro syringe module that handles all the diluent movement. We've got the gripper module, the vortex module. All of this connects internally. So there's a power supply in the back that's built into the back of the unit. The power switch sits on the bottom, kind of the back bottom right for everything, and it all gets incorporated into that. So it actually only uses a single USB connection and one power cord, and all the rest of the components are, of course, integrated to that single source. So I want to highlight some of the details here as we go through these features. I'm going to start with the gripper. Obviously, the gripper is critical because that's what allows us to analyze the tubes individually and really get the accuracy that we needed. So it'll move the sample tubes move the dilution tubes really from the rack to the scale to the vortexer and back to the scale and back to the rack, right? So that's what handles or facilitates that, allows each tube to be weighed 3 times. It uses silicone gripper tips. We expect these to need to be replaced about every 6 months, but so far they've been testing really, really well and haven't need replaced on our units. And one thing that's critical about the gripper is it only works with the 14, 15 ml tubes. So it will not work with the smaller 8 mils. It will not work with the larger 50 mils. It is specific to these size tubes, but they are also the most common tubes in the oils market. The pipetter is a custom pipetter that's attached to a 2.5 mil precision syringe. So the picture here shows both the syringe and also the pipetter attachment on the bottom. The syringe is controlled by a motor that's built into the Z drive. And I mentioned that there's custom firmware. That's how we confirm the presence of the pipette tip during pickup. So if the tip isn't there, it'll recognize. The target sample volume is determined by the dilution factor, and the software is designed to optimize that sample uptake without dirtying the pipetter. So pipetter stays clean, it never touches sample. And the software, again, will automatically adjust the dispense step to compensate for different viscosity samples. So I'm going to give you a little more information on that. What we actually do is we pull up an air gap, then we pull up the sample. Then once the empty tube has been weighed, we go to dispense, and the whole volume that's in the tube, or that's in the syringe, everything's been pulled up. So all the air in there is divided into 8 segments, which are broken down into like little pulses. So the way it actually dispenses, it'll take the first half of those segments and add them in slow bursts, right? So it does a little push, and then it'll wait for a quarter of a second, does a little push. And the waits are to allow the oil to kind of regather at the bottom of the pipette tip, because we found that if you try to push too fast, you just create a channel of air through the center of the tip, and you don't actually get the oil off the sides of it. So by taking our time and doing short bursts, we're able to get much better, more effective dispensing. So what the software does, I said it's a 2-step, so it'll do the first half of those pulses, and then it takes an intermediate weight. And if there is enough sample weight in the tube to dilute well and have a good amount of final volume, then it will go and simply get rid of the pipette tip. If there's not enough sample weight in the tube at that point, essentially we set a cutoff, and if it's below that cutoff, then it does the second half of the pulses of additional pushing to try and get everything that we can out of the pipette tip. It's not necessary for lighter oils, but for your heavier, anything above like 600, 800, 1,000 centistoke, a lot of times you'll need that extra push to try and get enough sample into the tube to be able to have enough final volume. So but it automatically compensates and adjusts to handle the different viscosities. The level sensor is built right into the pipetter. So actually, I'm going to go back a sec. So you can see there's a tube that kind of runs up behind the syringe there, a little clear tube. That connects to the level sensor. So it's built right into the pipetter. It's used on every sample, regardless of the container or rack. What it is, it's a pressure sensor, and it recognizes when the pipette tip enters the liquid. So essentially, each pipette tip comes with its own little column of air inside it. I know we don't think of them that way, but it does. So when you pick up the pipette tip and seal the top, you've got this column of air that goes all the way through the bottom of the tip. This pressure sensor will recognize when that's open to the air around it, or when it becomes a sealed column of air when the bottom of the tip hits liquid. After that liquid is detected, then it moves down some additional, it's like, I think 3 millimeters, some additional millimeters, just to ensure that you get minimal oil on the outside of the tip, but also we want to make sure that we don't aspirate ourselves, or aspirate to the point that we have run out of sample at the level that it stops. So that's why it moves down a little bit, to ensure that you get a good aspiration. Now this feature is really, really critical for customers using sample bottles that tend to maybe not have the same volume in them, but it's also, or really anytime you've got varying sample depths. So we talk about using this with bottles, but it's also really nice if you're doing a pour-off step, like into sample tubes. You can dispense or aspirate out of those sample tubes, and then if there's human error in how much sample you get into that tube, you've got a lot more freedom, because the level sensor will automatically adjust how far down it goes. The pipette tips, obviously critical for this, right? New tip for every sample. This is what really maintains our cleanliness. The preferred tip brand is Oxygen. It's a Corning brand. It's available through multiple vendors, including Fisher Scientific, Amazon, Corning themselves, of course. We will also be selling these pipette tips, but we make automation. We don't make pipette tips. So we're going to just do our best to make them as accessible to the users as possible. But I will say you must use wide bore 1 mil pipette tips for the sample aspiration. And we really can't guarantee system performance with other brands or styles. Now, each pipette tip rack, the rack is kind of pictured here. That includes 100 tips, and they're actually sold by the box, which is 1,000 rack, or the box is 10 racks, or 1,000 tips, or by the case, which is 5,000 tips. The scale itself, it's an off-the-shelf A&D scale that's fully integrated into the system. It's connected with a serial connection in the back, which handles both communication and power. The scale itself sits kind of under the deck, but not on the bench. So it actually sits on a floating plate under the deck, and that helps to isolate it from vibrations because it's floating, so it's not actually on the table, but it's also kind of floating free from the automation too, so it's isolated from the vibrations. It also has a custom cover. That cover helps to protect it from drips and spills. And in some of the other pictures, you'll see like this little chimney going up where the tubes actually go in. That's part of the cover that sits over the scale. So the cover protects it from drips and spills. It also isolates it from other interferences, like when the fan kicks on and that sort of thing that can happen in the room, to help maintain the accuracy of the scale itself. The Vortexer, this is an adaptation of a previous Vortexer we've made for a different product on our sample dilution accessory. It was modified to work with the gripper and 15 mil tubes. I mentioned the vortex time is adjustable, with 20 seconds being the default, 60 seconds being the max. And the diluent, like I said, we've worked a lot with how we add the diluent to make sure that we get really good homogenization, and found that it works really well to add the diluent across the duration of the vortex time. So if that's 20 seconds or 60 seconds, it'll automatically adjust the speed at which the diluent is added. And then there's a short burst, usually at the end of the diluent addition. There's a short burst that helps really provide optimal homogenization by ensuring that everything gets mixed well. The diluent syringe and probe, this is a Cavro syringe with Cavro valve. We've been using the Cavro parts in the oils industry for 20 years. We have a lot of confidence in their systems. They're a great partner to work with. So we're basically sticking with that because we've had extraordinarily good success in this marketplace with these solvents in the past. So all diluent movement is controlled by the 25 mil Cavro syringe that connects to a beveled stainless steel diluent probe via polyurethane tubing. Again, the diluent probe never touches the sample, so there's no contact. And as I mentioned, the sample weight that's measured actually determines how much volume this syringe will aspirate and then dispense into the tube. And kind of the last detail I want to keep here is the sample racks. So for your final racks where you're going to have your diluted product, we have to use 15 mil tubes. So that means that the 60, 80, and the 96 OE4 racks are all compatible and will work well, but you have to use metal racks. The plastic Bellart racks have too much wiggle because they're square or rectangular holes. They don't hold the tubes precisely enough for the gripper. So you have to use the metal racks that actually have the round holes. But then within that, the 60, 80, and 96 will all work well, and those are all automatically built into the software. For your raw sample racks, you can use bottles or cups or tubes. There's a lot of freedom as far as what you dilute out of, but restrictions on what you dilute into. So you can we have 45 and 32 position bottle racks that are available and supported. We have 90 position cup racks. Again, those are for these little 2 mil graphite furnace cups. And of course, any of the standard tube racks, those will work well. And there's also custom rack options available. Frequently asked questions. So precision, accuracy, and carryover. I've talked about accuracy a lot. 0.1 milligrams. Everything is weighed on the scale, and that really determines our accuracy. The carryover, we really get zero carryover because there's no sample-to-sample contact. But precision, I haven't talked about at all. So we actually did some testing with a 1200 centistoke oil. That's kind of as a worst-case scenario. And we ran that at a 10x, 50x, and 100x dilutions to see how repeatable is the final dilution factor that's produced, right? That's what's going to determine your internal standard. That's what has to be really precise. And what we found is that for the 10x, 50, and 100x dilutions, the RSDs came out about the same. I mean, we're at 0.1% RSD. So very, very precise as far as that dilution, the final dilution factor is concerned. It's extraordinarily reliable to produce that data again and again and again. What type of sample types does it use? Well, we're talking organic samples, newer used oils. Will both work. Liquid samples only, no solids or greases, which goes hand in hand with the limit of 1,000 centistokes or lower. Anything beyond that, I mean, you could try it, but we can't guarantee performance. And one thing, of course, we're going to get questions on is aqueous sample types. That may be something we consider in the future, but for what we're looking at now, we really want to focus on getting this solution to the new and used oil market, because that's where we saw the biggest need. The time per sample, the manual sample preparation we discussed typically takes 2 to 5 minutes per sample. The automated sample preparation still takes about 2.5 to 3 minutes per sample. So sometimes it's faster than some analysts and possibly slower than others. And the reality is that just all the things that have to be done that take time in the manual process still have to be done and take time in the automated process. You still have to wait for the liquid to move in and out of the pipette tip. You still have to wait for the scale to stabilize. You still have to wait for all of the steps. You have to do the vortexing, right? And all of that takes time. So the time requirement is still there, but the great thing is that you don't have to be, if that makes sense. And also the software includes that delayed start option. That's one of the things, one of our beta sites absolutely loves that, because they'll set up the system up the night before, and then when they come in the next morning, everything's prepped. Maintenance and consumables, always a growing concern on this. So the primary consumables for the system are the 14 or 15 ml tubes and the pipette tips. All right, you have to use one of each for every sample. The gripper tips themselves need replaced every 6 months or so. And then the diluent probe and the rinse and waste tubing would need replaced probably yearly. And that's it. Like, that's all the consumables on the system. Basically, it's your pipette tips and your sample tubes, which most of the time you're going to be using those for a manual process anyway, so it should be pretty close to a net zero. And then conclusion, right? This is a simple automated gravimetric sample prep station. It's really the first of its kind. Automation, as well known, reduces manual error, improves reproducibility. It removes a lot of the questions that we run into in labs about who prepped the samples, and simply provides this reliable solution that doesn't take vacations and doesn't get sick and doesn't have holidays and all of that. Zero carryover with importing and exporting. You'll never incorrectly key in a weight again, and it fully meets the ASTM D5185 and D4951 requirements for sample preparation. But also, I mean, what we started with, right? Let robots be robots. And then if you let robots be robots, you can let people be people. So with that, I want to thank you all again for your attendance and your attention. We're going to open it up for questions now. So if you haven't already submitted those, feel free to submit in the chat box, and we will go ahead and start addressing those. Okay. So I do have a question here. Is it compatible with the PerkinElmer Syngistics ICP software? So this system is a standalone diluter. It doesn't connect to the ICP. It does require that you transfer the sample over to usually a separate auto sampler. And that's because as it takes such a long time to do the sample preparation, we didn't want to tie up the ICP for all of the time that it takes to do that. But it also, in a sense, is compatible with Syngistics because we do create CIF files. So when you export your data, you should be able to import that directly into Syngistics or WinLab. How can we ensure cleanliness of syringe before moving to next sample? Hopefully this has been answered. The syringe never contacts any samples at all. There's 2 syringes on there. The 2.5 ml syringe that's built onto the vertical Z drive, that only ever touches air. It doesn't come contact with any liquid at any point. The diluent syringe will only ever touch your clean diluent. And even the diluent probe that dispenses the diluent, again, it never comes in contact with samples. So there shouldn't be any sample syringe interaction, period. Let's see. That's a good question. Can different dilution ratios be used in a single batch of samples? Absolutely, yes. So the dilution ratio that you use is determined by the method that you select for your sample in the sequence, and you can select a different method for every different sample if you want to. And most of the time, you're going to use the same method for most of your samples, but if you wanted to use a different method, then you can simply select those samples individually and change them, or you can, again, put it into your CSV file of which method you want to use for that particular sample, import all that into your software, and then it will allow you to do different dilutions on a sample-by-sample basis. What is the maximum number of samples you can put on one single run? That really depends on your sample containers. So if you were diluting, for example, out of, if you wanted to use the 96 position OE4 racks, so you would have a 96 position rack for your finished samples, diluted samples. You'd have a second one that would contain your raw samples. In that case, you could do 96 samples. If you wanted to do only 60 position racks, you can potentially put as many as 6 of those on there, which would allow you to dilute up to 180 samples in a single run. But then if you wanted to use bottles, they take a lot more space on the deck, so you can only do about 45 at a run. So hopefully, I mean, it really depends on what your raw sample container is. Let's see. So you can use a barcode reader to import sample names into the list. We don't have a preferred types. I have tested this with just kind of an off-the-shelf barcode reader, and it works. But I think it was from Amazon, and I don't even remember the brand off the top of my head. It was just one that we got on Amazon that was pretty cheap, that plugged into a USB port on the PC. But that worked really well. So you can use that. So that's a good question. Traceability of the technician diluting the samples being recorded. We don't have anything in the software at this point that would track who's doing the work. So I don't have a solution for that. That would have to be something you'd have to track internally to know who's doing the work. But ideally, I mean, all that the technician has to do is put the raw samples on the deck and start it. So there's not a whole lot that should vary by technician. Hopefully the system will actually reduce the variability of your lab on a technician by technician basis by automating the sample prep process for you. Okay, do the diluted samples have the same volume for every sample? Actually, the entire rack's the heights import. Okay, so no, the final volume will vary from sample to sample, because the final volume is actually determined by the weight of the oil that goes into your sample tube, and then that will affect. So your final volume will not be consistent. It will actually change on a sample-to-sample basis. That said, if your samples are similar in terms of viscosity, or if you're diluting the same sample multiple times, then you'll come out with very similar final volumes. But if you had, something that was like a 75 centistoke next to 1,000 centistoke next to a 500 centistoke, then you may get some more significant variances in your final volume. We do our best to ensure that it gets to kind of an optimal volume of 8 to 10 mils, but for some of the heavier samples, it's really difficult to pipette and dispense them. So in those cases, you might wind up with something more like 5 to 6 mils. So there's going to be some variability there. The really critical thing is that your dilution factor will remain constant and consistent all the way through. Is the scale easy to calibrate or check? Performance as part of a daily quality check. So you can go in the manual part of the software to check the scale. So if you wanted to do a daily check, it would be really easy to put a known weight onto the scale and then check it in the software. Basically just tear it, have it go ahead and give a read and make sure that it's being consistent. So that would be a simple thing to do on a daily check. And then the scale, as we mentioned, it's an AMD scale. It's an off-the-shelf brand. So however you're currently doing your calibrations, most of the time the group that's doing that kind of calibration work could also cover the scale that's integrated into this system, simply by removing the cover, and they'll have access to everything they need. Okay, I'm scrolling through these questions. I think I've already answered a lot of those in the presentation. We did have the, yeah, so CSV file import to Syngistics, fill up the sample info file too. So the sample info, the SIF files are they're separate from the CSV export option, but you can select to get a CIF or a CIFX file to have your data exported that way rather than as a CSV. And that's what you would use for Syngistics or WinLab. Could you imagine to bring a version of this instrument for automated acid dilutions? It is something that we may consider in the future, but it's not something we're pursuing at this time. One of the biggest concerns would be, especially the heavy acids tend to eat away at metal components that we've used on this system, so we'd have to look at that really carefully before we went down that route. So yeah, blank oil dilution. I've got a couple questions here, I think, about the same thing of can we do for really concentrated solutions that you have to do a two-step process, can that be handled by the system itself? And at this point, no, that's not something we've come up with a good way to handle. It may be something that we consider adding as an additional feature in the future. But this was really designed to optimize that final step of preparation to make sure you get your internal standard well mixed. But it may be something that we consider going forward of a way that you could add both sample and like a blank oil both to the same tube and then add your diluent. Can you make different dilutions from the same sample? Absolutely, yes. So that's one thing that the level sensor actually makes really easy, is you can send it back to the same exact sample tube and say dilute 1 to 10 or 1 to 50 or 1 to 100, or do each of those in a row. And it'll, with the level sensor, it automatically adjusts how far into the tube it goes, and it makes it really, really simple. What is the lowest viscosity that can be used with this instrument? So, I mean, we don't have a clear low end, but I mean, it dilutes kerosene great. So it's not something we've got a specific spec for, but I mean, we've done stuff all the way down to 30 centistokes or lower. Most of the time, if it can dilute the solvent, fine, then it will handle your oil samples well. In addition. How is the test tube supported when it's being weighed? So it's not. So when the test tube is actually being weighed, the gripper places it on the scale, and then essentially like the chimney that goes up around on top of the scale cover, that ensures that the tube isn't contacting anything else and is basically just standing directly on the scale itself. So it's not, the tube's not in contact with anything else. It's not suspended or hung at all. It's just sitting on the scale. And the cover ensures that it doesn't fall over. Okay, how many samples did you run for your precision test, and what was the sample to sample time for the 1200 centistoke? We ran for the precision test that I showed. That was a pretty simple one. So we did that oil, each dilution factor, so the 10x, 50x, 100x were all done 5 times out of the same sample container. I wasn't tracking how long it took per sample, but I would guess it would be around 3 minutes. But I wasn't specifically looking for it. Honestly, I set up the run and I walked away and let it do the work, and then I just examined the data at the end because that's the point of this system. So I hope that makes sense. What is the maximum sample lab number that the program allows? At this point, it'll go up to 10,000 as far as its how it counts. But again, if you had a CSV file and you put your sample lab number in there, then there's no limit. It'll go up as high as you want. As far as the software counting automatically for you, where you put in the number and it'll count the samples, that goes up to 10,000 at this point. If it needs to go higher, let us know and we can certainly bump that. But that's was significantly more than what our beta sites needed, so we figured we're pretty safe at that number. Is the dilution system detecting if there's no dilution tube on the defined position? Absolutely yes. So there's a lot of intelligence built into the system. So yeah, if there's no tube, the gripper will try to pick it up. The gripper won't realize there's a problem, but when it goes to put something on the scale that isn't there, we'll get a readback of there's nothing on the scale, and it'll say, hey, there's a problem, there was no tube, throw an error message, it will, and then respond appropriately. Essentially, anytime it encounters an error, the system will do its best to clean the deck and then keep working. So in many error cases, like we didn't get enough sample, for example, like if it tries to aspirate out of a location that there is no sample there, like you accidentally send it to the wrong location and it just aspirates air, when it goes to dispense that into the tube and dispenses just air, the software will pop up and say, hey, we don't have enough sample to continue the run. It'll put the empty tube back where it started, dispense the pipette tip, and carry on. And that's how most of the time, if there's an error, we'll catch it on the scale and know that that's not a valid value. There are a couple cases where the software will recognize there's a problem, but rather than continuing on, it'll actually stop the run. For example, if for some reason the tube gets stuck in the vortexer or something goes wrong with the dilution and it doesn't feel, and the system isn't sure that there's not a tube somewhere loose, then it will stop. But that shouldn't happen. All the main errors that you would run into, like user error stuff, if we forgot to put a sample tube there, we forgot to put, we had it try to aspirate out of an empty tube, that sort of thing, it'll recognize there's a problem, and it should automatically just throw an error for it, kind of give you an idea of what went wrong, and then carry on to the next sample and try to continue its work. So that's a really good question that I didn't touch on. Thank you. So what are maximum and minimum sample weights? And I think this is the last question I'll do because we're already over the hour. And thank you for all the good questions. I'll do these last two. So maximum and minimum sample weights that can be done. So the sample weights are really determined by the software, not by the user. So you don't specify that you want 0.5 grams. You specify that I want a 10x dilution. And then the system does its best to facilitate that as well as it can to get to an optimal final volume. So there is no minimum or maximum weights because that's not user specified, that's system specified. All you need to tell us is what dilution factor you want, and we do our best to produce a good final result with that. And then how is diluent fed into the instrument? Is it similar to a rinse bottle set up for an ICP autosampler? Yes, so the diluent is fed in to the system by a 25 mil Cabro syringe. So that syringe is connected to a probe that will go to the top of the sample tubes during vortexing to add diluent. The syringe, so it's connected to a probe on one side and the syringe is connected to just a rinse bottle on the other side. So you'd have a liter or 2 liter bottle there, or larger container if needed, that would feed out of, and then the syringe simply aspirates from the big bottle and dispenses that into the tubes appropriately. So with that, again, thank you for your attention. Thank you for the excellent questions. I really appreciate your time and staying through to the end here. And with that, feel free, if you have any other additional questions, to reach out to us. We'd love to chat with you more, answer questions, give you more information. We're really excited about this new system, and we hope that it will prove to be an excellent resource for this market going forward. So thank you again, and I hope you all have a wonderful rest of your day.